Hey there, everyone, and welcome back to comp102. This is lecture number 10, and we have got two really important topics lined up for today: environment diagrams and Lambda functions. Environment diagrams will help you visualize exactly what Python is doing behind the scenes, and Lambda functions will give you a really cool new way to write short and throwaway functions. If you survive loops, then congratulations. This is going to be your next official boss level. So before we dive into the new stuff, let's do a quick warm-up from the next lecture and make sure that we are on the same page. All right, take a look at this code. We've got two functions here, add and mult. The question is, what exactly gets printed when you run this file? So go ahead, pause this video, think it through carefully. And I know you want to skip ahead, but resist the urge. This is not a WhatsApp voice note. So let's walk through the code line by line. In this case, add 1, 2, this line here. So this is basically, it does return 3, but nobody's printing it or storing it. So it just quietly disappears, kind of like your motivation after week 5. And what about that one? It basically prints the return value of add. Now we are actually printing the return value on the screen, so we get 5. Mult 3, 4. So this one is tricky because mult uses print inside the body, so it prints 12 on the screen on its own, but it doesn't have a return statement, so it returns none. And then you have this statement, it's printing the return value of mult, but since mult prints 21st, and then it prints, and then the print receives none back, and then that prints 2. So you get none on the screen. So it first prints the value of the product, and then it prints the return none. Okay, next one. So this function is supposed to check whether a number is a triangular number or not. What that means is it can be written as sum of values 1, 2, 3, 4 all the way up to for any number k, for example. But this code has a couple of problems hiding in it. So pause the video and see if you can spot them. There are actually two bugs. First, we are using the print, where we should be using return here in this case. Right? Without return, the function doesn't actually stop. It just keeps on going on, always printing the false at the bottom. Or besides, if you take a look at the requirements, it explicitly asks you to return true, not print anything on the screen. So that's wrong. Secondly, the other bug is here. In this case, it's going up till range n, but we want to add numbers from 1 and including the upper limit. So this is going to be n plus 1. So that's another bug. All right, so let's get into the main event, the environment diagrams. So this is where we get to peek inside the Python's brain and see exactly how it manages your code. And yes, Python does have a brain. So exactly what is an environment diagram? It's a visual tool that lets you trace through a program step by step. It shows you the program state, which is in the memory. It keeps track of these three things, basically: variables and their current values, function calls and the frames that they create, and the scope. Scope is basically, we talked about that, is the lifetime, which tells us where each variable is accessible to us. So every program begins with something called a global frame. Think of it as your main room where everything begins. And every time you call a function, Python opens up a brand new frame, and that is like a little side room just for that function that to do its work in. So let's start with something simple. 3 lines of code, no functions at all. When your program runs, it creates something called a global frame. And then it sees your first instruction that's called x equals 10. It puts x in the global frame, which is a variable with a value of 10. That's the same, exactly the same story with y. So let me just quickly, yeah. So that's the same story with y. Y equals to 10. And then for z equals x plus y, Python looks up the value of x and the value of y in the frame and then adds them together and stores back in z. So that's how addition works, and that's how it knows the current value of the variables. All three variables live right there in the global frame. Nice and straightforward. Now let's see what happens when we define functions. When Python encounters a definition of a function, let's say here in this case it's defining add a and b, it does not execute the body, as we know. It simply creates a function object and stores it into the global frame, something like this. So same happens with mult. Both are stored and both are waiting. Nothing runs yet. So defining a function is kind of like a biryani recipe. You don't start cooking because you wrote it down. You cook it when someone says, I'm hungry, make it. Now here's where it gets interesting. We are actually calling the function. When Python sees add 5,3, it creates a brand new frame called add frame. Inside that frame, it binds the arguments. A gets a value 5 and B gets the value 3. Then it runs the body of the function, which is, in this case, return A plus B, as you can see on the screen, which evaluates to 2 in this case because A is bound to 5 and B is bound to 3. So that 8 travels back to the caller, and the result in the global frame gets the value of 8. And the add frame, it's done. Basically, as soon as you return from the function, Python is going to destroy it right away. So now let's talk about something really important here. Local frame exists only in their function frame, but we have a global variable which is x, as you can see in this case. So when you run this code, the global frame will be created and the variable x will be value with the value 100 will be created inside the frame, and also the function name, which is contained in the variable called compute, will be created inside that. So compute is essentially a variable that points to a function. Now what happens when you call the compute function? This is going to create a new frame, and that is going to hold the value of its local variable, that is y. Now what happens when you run this instruction called z equals to x plus y? Now in this case, we have the value of y, which is already inside the frame, sure. But where is the value of x coming from? So since we cannot find the value of x in the function frame, we have to go up and search for that in the global frame. Can we find the value of x in the global frame? Yes, sure we can. So then we get the value, we add the values of x and y, and then that's going to be the result, which we store inside, again, the function frame, which is the compute frame, right? And then we are returning z from the compute, which is copied back to the global frame variable, which is the result. So this function frame delegates result to the global frame, and then in turn it is completely destroyed. So that's how it works, right? So local variables are kind of like your class nodes. They only exist in that room. Global variables are like Wi-Fi passwords. They are accessible from anywhere. So you see this red X on the diagram. That means that the frame is destroyed along all of its local variables, which means that these local variables will not be accessible anymore. And in a nutshell, this is basically what we call a scope, the lifetime of the variables. So it's kind of like trying to use a local variable outside its function is like trying to use your FC student card at Punjab University, for example. All right, it's your turn. I want you to draw the environment diagram for this code. Pause the video, grab a piece of paper, and actually sketch it out before moving on. So we end up with 2 frames in total. The global frame holds square as a function object and y with the value of 16. And the square frame, which is the function frame, has x bound to 4, and it computed and returned 16, and then it gets destroyed. So if you got that right, excellent. If not, try rewinding and trace through it again. What happens when we call the same function more than once with different parameters, or even same parameters, doesn't matter. Each call gets its own completely separate frame and they don't share anything. For example, initially it's going to create the global frame. Then when you call a double with the value of 5, it's going to create a local frame and it's going to put the value of n with the 5 in it. It goes to the function, replaces the value with the 5, and then in the next instruction it's going to double the value and then it's going to return it. In this case, it's going to return 10, and then the frame is going to disappear after returning the value to the global frame. Now you do the second call. The second call is going to create a brand new frame where n is 10, and in this case it's going to return 20 to the global frame, actually precisely to the value, to the variable that is inside the global frame. And then after returning, immediately that frame is going to be destroyed. So at this point you only have the global frame behind. So far we've been passing numbers and strings into the functions, but here's a wild thought. What if the thing we pass into a function is itself a function? So passing function as a parameter of another function. In Python, functions are what we call the first class objects. That's a fancy way of saying that we can treat them just like another piece of data. You can store functions in other variables. We can assign the function to a variable, for example, and you can pass it as an argument, and you can even return it from another function. So a higher order function is simply a function that either takes another function as an input or returns one as an output. Watch what happens here. First we define a function, and then we assign that function in a variable called say hi. So if you take a look at this closely, there are no parentheses after greet. We are not calling this function. We are just giving it a second name. So global frame is going to create the function, and this is an alternate name that we gave to the function. So this function now, the function definition is being treated as a data, just like numbers. Both greet and say hi point to the same function object. You can call it either one and get the same results. For example, in the lines here, we are calling say hi with the parentheses and with the value. It's going to give us the greeting, and the name of the function, we call the function with the original name. It's going to give us the greeting in the same manner. So both name refers to the same function object. That's the key point here. So this one is a big idea. Functions in Python are just objects. You can pass them around, store them in variables, and return them from other functions. Once you internalize this idea, the whole new world of programming patterns open up. So here is a high order function in action. Apply twice takes a function and a number. So as you can see here, this parameter, it takes a function, and this parameter here, it takes a number. So how do you know that this is a function and this is another integer, for example? So that basically whoever wrote this function is going to tell you, and this is usually written in the doc comments, which are missing incidentally in this case. If we pass in double as the first parameter and the number as the second parameter, what's going to happen is apply twice is going to apply double to the number once, and whatever return value that it returns is going to go back to the same function, which is double, and then it's going to double it again. So this number is going to double twice. So 3 becomes 6, and then double of 6 becomes 12. So apply twice takes a function as its parameter. Here it's a higher order function. All right, time to try writing one yourself. The function apply takes a criteria, which is a function, and a number n. which is an integer. So if we take a look at the documents, it says criteria is a function that takes a number. Criteria is okay. Read this very carefully. Criteria parameter is a function, which means a function is being passed as a parameter. That takes the function criteria is talking about the criteria. So criteria takes a number and returns a Boolean expression. And then you have n, which is the second parameter, that is an integer. And what's the output? It returns how many integers from 0 till n, including 0 and n, that match the criteria, for which if you pass that variable, the value inside criteria, it returns true. So you need to count how many values from between 0 and n, the criteria function returns true for those. So that's what you need to do. So pause the video, give it a shot, and before looking at the solution. Here's how it works. We loop from 0 to n, and for each number, we call criteria I. If it comes back true, we increase our count. And notice that we pass is even without parentheses here. So this is not, when you add parentheses to a name, it means that you are invoking that as a call expression, which we are not doing. We are just passing the value of is even, which is pointing to the function object as a parameter. We are not calling the function itself. So essentially, we are handing over the function itself, not calling it first, right? You can think of it as parentheses mean that you're calling someone on the phone, and parentheses, and without parentheses, you're handing your cell phone to someone. So that's a big difference. Sometimes you'll just need a tiny little function that you use once. Writing a full def statement, the one that we write for creating function definitions, that's a kind of an overkill. That's exactly what Lambda is for. It lets you create anonymous functions, meaning functions that don't even have a name. Think of them like a disposable plate at a party, right? So you use them once, you toss them away, and there's no washing up to do. So that's what these functions are kind of like that. Let's put them side by side. The named version, it says def even, and it has a body. So this is kind of full-blown function definition that we did earlier. And the other one is the anonymous version, and that is the Lambda. So basically, it's a single line with the Lambda keyword, and then we have a list of parameters, and then we have a colon, and after colon, there is a single line body. These two things, even though this Lambda has no name, but these two things do exactly the same thing, same parameter, same logic. Lambda version has no name and no return value, no return keyword in this case. The expression after the colon here automatically becomes the return value. So that's important, which means that you're only allowed to give just one expression in a Lambda expression. So this is going to be an expression which is going to resolve into a single value. There is no body inside. So there are no multiple instructions inside a Lambda. So this is a simple cut down version of the full-blown function definition. And since there is no name here, the catch is that this is a one-time deal. Since you have no name, you cannot refer back to it, and you cannot use it later unless you store it in some kind of an external variable, as we saw earlier in the previous slides. We have a function called apply, and that takes a function as a parameter, and another parameter is a value 10. So let's trace through a bigger example with a full environment diagram. In practice, you can use either one. Apply is even basically this one, and also this one, in which you are passing the entire function as a parameter. This is Lambda expression. So this is the power of Lambda expressions. You can simply pass the entire thing as a parameter, and the code, the parameters, the logic, everything exactly you can write here inside this line. And both of these functions are going to give you exactly the same result. So they are one time and you cannot reuse. So now let's trace to a bigger example with a full environment diagram. So first, the global frame, it picks up do twice function as a function object. Then we call it with with the parameter, the value of n is 3. And what about the function? That's the second parameter here. So that second parameter we pass in the lambda object. So basically what lambda object is doing, we have the keyword lambda, then we have the parameter, and then we have colon, and after colon we are going to give an expression. So whatever this expression boils down to a single value, that single value will automatically be the return value of this expression. Now Python evaluates the inner call. So for example, in this case, it's going to be this one, but with the value of n substituted to 3, where the value of n is coming from, that we passed here from this function, do twice n. And then it returns 9, and then the frame basically gets destroyed. It returns it, and then it gets destroyed, right? Then the outer call, that one, it's called, and it opens up another lambda frame. This is going to have the value of x as 9, and then it returns 81. So after that, it returns 81, and then that frame is destroyed. So now the inner functions, these little lambdas, they just calculated the value. We got 81, and that 81 will be returned from do twice, and then that's exactly what we print. But once the do twice returns this value, that frame will be destroyed, as you can see here. So 3 squared is 9 and 9 squared is 81. If math felt dissatisfying in O levels, we'll all be mathematicians by now. Okay, a word of caution. Lambda is only meant for a simple single expression operations. If you need multiple lines documentation or plan to reuse the function, stick with def. Lambdas cannot contain return, they cannot contain loops, they cannot contain if statements. It is just one expression. So that's the important point. And watch out for the two most common syntax errors. So forgetting the colon after the parameter, for example, in this case, that's an error. You have to put a colon there. And there are no return statements in a lambda expression. So there are very limited versions of functions, and they have their own use cases. Lambda is like a kind of like a IKEA, perfect for short trips around the block, but you wouldn't take IKEA to Islamabad, for example. So long journeys, you use def. That's your devu bus. It's not a summary yet. We have one more topic, and that's the closures. So that's one more concept we need to do before the wrap up. A closure is what happens when a function remembers the variable from the frame it was born in. So for example, here you have make adder, and it contains the function adder. So basically you can say that the adder was born in the function make adder, which means that even after the frame is destroyed, adder is going to still remember the variables from make adder. For example, let's say you have add 5 equals to make adder, and you run it with the variable with the value 5. So first you have the global frame, and then make adder goes there, sure. Then you call make adder. Basically now you create a new frame, all of the local variables go inside it. And then please note that not only the local variables, which is the parameter, that goes inside it. You also have this function which you create inside the make adder that also goes inside the make adder frame. The scope of this is make adder frame. It cannot be accessed from outside. So now you're returning that adder function basically. So you return that to the global variable called add 5, and then when you call add 5 with the parameter 10, what happens is the value of n will, so basically the value of x is coming from the error frame, which is 10, right? But where the value of n is coming from, because you don't have n in the global frame, right? But you do have n in the local frame of make error, but there is no make error local frame. Even though we cannot see the frame here, but it still exists, but that frame is accessible except for error. We can actually go ahead and do this example in Python tutor, and let me show you what it looks like. So this is our code. First, if you press the next button, it's going to create a global frame, and then add make error is going to exist, be created in the global frame, and then you add 5 equals to make error. Now make error, since we are calling a function with parentheses, it's going to create its own local frame. Again, remember, whenever you call a function, this call expression is going to have its own local frame. And in that local frame, you have the value of n. But what about the function that you're creating inside the make error? So now that goes inside the make error frame as a variable here. Again, you're not calling this function, and then you're returning error. So what happens next? The return value will be error, and then that is stored in add. So in your global frame, you have two variables now, make error and also add. And when you invoke add with the value 10, what happens is it's going to create its own local frame. And you see that the make error frame is grayed out, meaning that it exists in the memory. It's not completely destroyed, but you cannot access it from outside. The only function that can access is the error. So this is what a closure is. Closure means that the function remembers its environment that it was born from. And in this case, error was born from make error, which means that now if you run error, even though the parameter contains x, and there is no hint of what n is in this case, but it still remembers its parent frame, and that the 5 is coming from its parent, which is make error. And the return value will be 15, and that's what it returns basically. So let's break it together. Environment diagrams let you trace execution visually. Every program has a global frame. Each function call creates a local frame, and those frames get destroyed the moment the function returns. Higher order functions are built on one simple idea. The functions are the data. You pass them around and return them just like numbers or strings. Lambda functions are anonymous one-liners with the syntax, lambda, list of comma separate parameters here, and the colon, and then a single expression. And this is perfect for quick jobs, but reach for the entire def syntax when you have things that get more complex. And that's a wrap for lecture 10. Make sure you practice drawing environment diagrams on paper, and I guarantee that they will show up on your exams. So try playing around with higher order functions and lambda functions on your own. The more you experiment, the more natural it'll feel. And do use Python tutor. That's a very amazing tool at your disposal. And remember, if the code is not working, draw the diagram first. If the diagram is not working either, well, that's what the office hours are for. So see you next time. Bye-bye.